Hi, my name is Eric Spengler, and I'm going to be doing a demonstration of an IPsec connection between two Windows 2003 servers. Now, what is IPsec and why am I going to demonstrate with the servers? IPsec is a suite of cryptographic protocols that are used to provide confidentiality in communications between computing systems. Very popular in technologies such as VPN technologies or protecting data from hosts to servers for many different types of communications. They use many different types of encryption protocols such as DES, triple DES, AES, and then various hashing and authentication algorithms such as SHA, MD5, and HMAC. Now, what I'm going to be doing is a demo with Windows 2003 to 2003 server, and the reason why I'm going to be doing that is because it gives the students a good way to really look at what's happening within their Windows environment, and it's easy to configure and easy to utilize and demonstrate. So I'm going to look down now at my system, and on my system I'm set up with Microsoft Virtual PC, and within this Virtual PC environment I have two Windows 2003 servers set up. As you can see, they're labeled Windows 2003 Server 1 and Windows 2003 Server 2. In addition to this setup, my Windows 2003 Server 1 has a tool called Wireshark, and Wireshark provides that facility which allows me to evaluate the packets to in fact verify that the encryption is taking place. So let's go ahead and perform the configuration. To start the configuration, the first thing I do is I pull up the Microsoft Management Console by clicking Start, Run, and MMC. From this point, I'm going to add two snap-ins. One snap-in is called the IPsecurity Monitor, and the other snap-in is called the IPsecurity Policy Configurator. Now, what I need to do is I need to create an IPsec policy on my Windows 2000 servers. And actually, I have to create both policies on each of the servers that are similar in order for the communications to take place. I've already pre-created a policy on the second server, and so I'm going to be giving a demonstration on the first server. So, to create a policy, first thing I do is add the policies to my system. In fact, I already have a policy out there. I'm going to delete that policy. And you can see that there's default policies that are already created for us. And the default policies are provided by Microsoft to make it easy to enable IPsec communication between systems. I'm going to go ahead and create a new policy by right-clicking in my MMC and clicking Create IP Security Policy. Now I'm going to call this CCNA Security, and this is pretty much a Windows-driven wizard system to create these, but it does have a nice correlation between what you can do on the Windows machine and what you can actually do on the Cisco routers, and it gives a good synergy of understanding between the two environments. So I'm going to deactivate the default response rule, and I'm going to click Next so that we can go ahead and start our policy configuration. Now generally, when I do this, I unclick all the Add Wizards because the wizards will step you through, but I'm going to go ahead and manually create this policy without wizards. So I uncheck down at the right-hand corner the Add Wizard. So I'm going to click Add, and you'll notice I come up with a rule. Now what a rule is a rule allows that IPsec configuration to be enabled in the traffic that's traversing from the application layer down into the network layer and beyond below, because the IPsec is actually inserted at the network layer. So we're creating a rule that will actually be inserted to the traffic that passes through the network layer. We have three items that need to be created to create our policy. The first item is an IP filter list, and the IP filter list would be equivalent to the interesting traffic access list that we create on our router. The filter action would be equivalent to a transform set. That's how the data is encrypted. And the authentication method would be equivalent to what we would do with a policy. How do we authenticate trust? Because effectively we have two phases. Phase 1 with an IPsec builds trust, and phase 2 with an IPsec actually processes the encryption of the data. So I'm going to start with my 3 items. The first thing I'll start is my authentication method. Now you can see it defaults to Kerberos, but Kerberos is assuming you have a Microsoft Active Directory domain. I'm going to add what we refer to as a pre-shared key. And my pre-shared key will be CCNA. Now it's very important that we remember the pre-shared key and we type it exactly the same as it's on the other system that we want to communicate with. And I'm going to move that pre-shared key authentication mechanism to the top so it's the primary authentication. The next item I'm going to configure is the filter list. The filter list, again, is identifying which traffic will be processed through this rule. I'm going to click Add and create a filter list called CCNA Security. Now notice I will uncheck the Use Add Wizard, and then I will click Add. Now you can see that in this particular case, I can identify source traffic, I can identify destination traffic, and I can identify even something as specific as the protocol in the information or the packets that I want to capture to process and encrypt. Now for our purposes, I'm going to go ahead and say my IP address, which is of course the source for my data, and any IP address or any destination, which means anywhere or any traffic that goes through this the network layer will be encrypted. And of course down at the bottom, since I won't be using a tunnel in this example, I will just click mirrored, which is required so that it can see traffic both directions. And I'll go ahead and select that CCNA Security filter list. The third and final item that I need to do to create an IPsec connection is a filter action. And again, the filter action determines, is equivalent to a transform set, determines what I'm going to actually encrypt and how I'm going to, not what I'm going to encrypt, excuse me, but how I'm going to actually encrypt that. I'm going to go ahead and, again, uncheck the Add Wizard and click Add. And go ahead and click Add to create my new security method. Now you'll notice that the primary security method before it's created requires me to select Permit, Block, or Negotiate. I'm going to click Negotiate, and this will allow my security between two systems to negotiate if it hasn't already started. Now it defaults to integrity and encryption, and I always like to give a little show that if I click Custom, what does that really mean? Well, with an IPsec I have some choices. I can encrypt what we call the encapsulation security payload, which is the entire packet, or if I only need to provide integrity, I can choose authentication header, and authentication header only provides integrity on the data with a trusted connection, but not necessarily an encryption of the data itself. So I have a lot of options that I can choose. The key part is that these options are the same between both systems. And you can see by default, I can click SHA, SHA1 or MD5, and I can click triple DES or DES. I can uncheck that, and I could click authentication header if I chose to do that. I'm going to go ahead and click on data integrity, but I'm going to check off authentication header. Now we have some settings below. Now this is interesting. Within the phase 1 and phase 2 for extra security, I can generate a new encryption key every so many seconds or every so many bytes of data transferred. I'm not going to choose to do that, but in some environments it's usually recommended to provide new encryption keys every so much time or data. Now, I'm going to go ahead and select integrity and encryption, and this will verify that I have SHA1 and triple DES being used, and I would do that on the same on the other side as well. Okay, so now this selects my security negotiation. It identifies I will be using triple DES encryption with SHA1 hashing. And I'm going to go ahead and accept unsecured communication at the bottom. And this is so that I can actually receive unsecured communication and respond back with a security request. Additionally, I'm going to select Allow Unsecured Communication with Non-IPsec Aware Clients. Now, normally I wouldn't do this. This option is required if I want or don't want to force encryption. By being unchecked, I'm forcing encryption. By being checked, I'm saying I will try to negotiate security, but if I cannot negotiate security, I'll go ahead and let the data pass anyways. So I'm going to go ahead and check it for now, and then click Apply. Oh, one thing about the filter action is, as far as the description, that's in the General section. So I can put a little description on there quickly. Now I'm going to go ahead and select CCNA Security, and now that I've configured my filter action, I've configured my filter list and my authentication method, I'm going to go ahead and click Apply. When I click Apply and OK, I make sure that my rule is selected. I click OK, and now I'm ready to do IPsec encryption between the two systems. Now again, a reminder that I did the exact same configuration on my second system, and it's required for both systems to have the same configuration in order to provide IPsec communications. The last item I need to do is simply enable my policy. I right-click on the policy, click Assign, and now my policy is enabled. And I'm going to switch over to the second system, and as you can see, my policy is not enabled. I'll go ahead and enable that policy as well. So now that I'm providing IPsec encryption, how do I test? Well, what I'm going to do is go to one of my systems. I'll go to system number 2. I'll go to a command prompt, and I will ping my first system. I'll use a -T, so it's an infinite ping. And as you can see, security was negotiated from the first packet, which means it wasn't communicating, but it was negotiating security. And then after that point, the pings or the communication resumed. Now, how can I verify that this is actually encrypting data? Well, there's a couple things I can do. Number one, I could go into my IP security monitor and look at my monitor. And under my monitor, I have main mode and quick mode. And main mode is equivalent to my SA, my Security Association 1 or Phase 1. Quick mode is equivalent to my Security Association 2, Phase 2. And so if I look at main mode, I can look at my security associations, and I see that I have an association with a pair of 1.1. And on the second quick mode, I see that I have a pair of 1.1. I have to have a security association for main mode and for quick mode. Now, how does it look at a packet level while we're wrapping up? Well, at a packet level, I can go to one of my systems, and I can actually bring up a tool called Wireshark, which I had mentioned earlier. And Wireshark should show me my encrypted packets. Now, because I'm doing an infinite ping on system 2 towards system 1, I should be able to see those encrypted IPsec packets. And in fact, here they are, and you can identify the protocol as ESP. Interestingly enough, I could be using any protocol because it's at the network layer. I could be using FTP, Telnet, HTTP, and all those packets, including ping, are marked as ESP. If I turn off encryption, you'll be able to see the packets unencrypted. So I'll go ahead and disable my policies. And in Wireshark, I can see the ISA-KMP, the ISA-KAMP deassociation. And the packets should be continuing to go as I see, unencrypted. As you can see, the packets are continuing, but they're continuing totally unencrypted. If I was to turn those policies back on, I should see a reassociation, and you can see my ISA-KAMP identity association is being created. And within a few seconds, I should see packets continuing to flow that are fully encrypted again with IPsec. And as you can see, the ESP is again being encrypted. Thank you so much.